Could you just start by telling me about your research just in general?
Well, I'm interested primarily in the impact of changing climate on landscapes and how landscapes interact with water. So I kind of look at the system through the lens of a hydrologist and how water, starting with snowfall and snowmelt and then rainfall, contribute to flow and flow in the rivers and the delivery of materials downstream to lakes or to the coastal ocean, which is an area of a lot of interest across the Arctic.
And what areas have you been researching?
In the last 10 years I've been focusing mostly in the Canadian high Arctic islands, so on Melville Island and some other sites. But over the last 20 years I've worked across the Canadian high Arctic, in Alaska, in parts of the Northwest Territories, and even a little work in Norway.
And can you tell me about any major trends or any major findings that you have made?
Well, I guess there's a number of different processes that are going on and appear to be changing. Some elements are more difficult to associate with trends. So, for instance, a lot of our work in the last 10 years is focused on one site on Melville Island where we've worked very intensively. And almost certainly we've seen some of the warmest years on record, but not consistently. So what we're seeing is the impact of one unusual year having a longer-term impact, even if it cools off in subsequent years. So, for instance, 2007 was the warmest year on record, and we had very substantial permafrost disturbance associated with that. And the impact of that was very strong in that first year, but we've been following it since, and it has a residual impact, a lasting impact. And what the problem is, we don't actually know how long that impact will be before it returns back to some sort of normal state, or if it does at all. We assume it will, because there's scars and geomorphic evidence that similar kinds of disturbance have occurred in the past. So we're really trying to work, and that's kind of a response to an instantaneous or one-time event. But there are changes that appear to be occurring that probably reflect longer-term changes in warming. We're starting to see changes in lake ice cover and adjacent sea ice cover in the areas we're working. And those appear to be much more persistent year to year. So, for instance, sea ice is much reduced in these areas, and it's an area where sea ice would be persistent through most of the year, perhaps even as late as 10 years ago.
How is permafrost connected to your research?
Well, most of the areas I've worked, permafrost is continuous and cold. So the thaw depth in a given summer is typically less than a meter. So it really controls almost every aspect of what we do. It means from a hydrological standpoint that the depth that water is actively circulating and is integrated or is functioning really is very shallow. And that's quite different from areas where permafrost is discontinuous or where it's absent. So that results in quite different runoff conditions, very short, intense runoff conditions. It also means that as permafrost changes, we start to see really substantial changes, particularly in water chemistry, less than we would see, say, in sediment transport.
So the permafrost thaw, how are the effects on the river and the systems that you have been looking at?
Well, the thaw has created a couple impacts that we seem to be seeing pretty consistently. One is that it's, in unusually warm years, it's generated disturbance. And those disturbances have had lasting impact in terms of delivering additional sediment and dissolved components downstream, and that's lasted for many years. In more general terms, we've seen those deeper thaw depths appear to be melting ground ice, and that ground ice seems to be relatively rich in dissolved materials, salts and perhaps organic carbon, and that material is now being flushed through the catchment. And again, it seems to be sustained for many years afterwards, or at least a number of years. So those are, I think, directly attributable to changes in the permafrost and the active layer thickness.
So how important is this research and for the Arctic and its environment?
Well, it has different kinds of impacts depending on how you look at it. This kind of landscape we're working in tends to be reflective of a very large area of the Western Canadian high Arctic and Middle Arctic. So this is an area approaching the size of Western Europe. It's uninhabited or largely uninhabited, but it's resource rich, and there's a history of resource exploration and potential development. So it's going to provide insights into how these regions will change in the future, and potentially as we start to see increased land use or land use intensity. So that's one issue, I guess, on kind of a regional basis. On a larger scale basis, it also means that we're starting to change the delivery of material through the rivers to the ocean. to the coastal ecosystems. And the coastal ecosystems in the Arctic are typically much more productive than many of the terrestrial ones. And as a result, this has potential impact on a much broader scale. And many of the communities in the Canadian Arctic have for long periods of time focused on marine mammals and traditional land uses on the sea ice and associated with sea ice. So changes in the coastal ecosystems have potentially very strong impacts on communities and people's utilization of those resources. So there's that sort of a regional scale, larger term scale, and of course there's an additional dimension, which is the greenhouse gases that might potentially be released through the melting of some or increased quantities of permafrost. And those numbers are poorly constrained at this point. It's not work I do directly, but there are people now starting to measure greenhouse gas emissions. And it appears that we're starting to see enhanced greenhouse gas emissions from particularly the soils. And that may be attributable to increased microbial activity in the thawed soil or the release of gases that were trapped in the frozen material. And that, on a large scale, if you scale it up anyway, could have actually substantial impact on global greenhouse gas budgets in the atmosphere, which of course is related to global climate change. So there's multiple scales, and of course we contribute different aspects to that. One of the things that's really come out of our work is the importance of trying to identify, actually, there's so much variability in the Arctic year to year. It's actually quite difficult to identify trends. Particularly in the hydrological system, where you can go from one extreme to another year after year. For instance, 2004 was the coldest year on record in our region, and 2007 was the warmest. So we've gone from one extreme to another. So that makes it very challenging to identify trends without long data sets. So we've really struggled because these are areas that have very few long-term monitoring programs. They're uninhabited. They're large areas, and they're difficult and expensive to monitor. So the result is we really don't have a good handle on whether or not we have solid trends or significant trends going on in these systems. So this is a real challenge, I think, for the scientific community, and it's certainly something we see in our work.